Previously in math class, at least that's what it felt like, right? I mean, we were talking about these calculations and these graphs and these lines and numbers and areas, and oh, who said math was going to be involved? Okay, well, not a lot of math is involved, honestly. It's one process, and once you learn this one process, this is the same process that technicians and laboratory technicians and entry-level chemists and anyone that works in a laboratory use every day. So this one process, if you feel really comfortable with it, you basically have the job. Congratulations. When can you start? Okay, so in the last video we went through and I gave you some insight of how I made the cholesterol sample that was ran on the machine. And I told you that I went into the lab and I weighed out 0.1 milligrams, and then I dissolved that into 100 milliliters of water, and we converted that over to a liter. And by taking 0.1034 divided by 0.1, I got 1.034, and that was milligram per liter. And we said that that unit of milligram per liter is the same as me writing ppm over here to the side, which means part per million. Okay, so this was the high standard that was ran. The concentration of the high standard was 1.034 ppm. That's how I made it. That's what was analyzed. Now, from the high standard, I made a middle standard. So this is what I did. I took a volumetric flask in a lab, and I added my cholesterol to it, and I diluted it up to the line, so 100 mils. And then, because I need what we call a calibration curve, I need to make multiple different standards. And we titled those as high, middle, and low. So what I did is that this volume, once I diluted it up to the line, I then took 25 milliliters of that liquid and I put it into another volumetric flask. And that volumetric flask was also, no, I'm sorry, it was not a 100 ml flask. I'm getting excited. See what happens when I get excited. It was a 50 ml volumetric. And I did this through a pipette, right? That's very important. Whenever we're making solutions in a laboratory, we want to use a pipette in order to do those. So I took a 25 milliliter volumetric pipette. I pipetted out 25 mils and I put it into this flask and I diluted up to the line. Okay, well down here at the bottom, what is the concentration of this solution that I made that we have titled middle? How can I do that? Well, think about it for a minute. I took this liquid and I diluted it to make this liquid. That's a very key word, diluted. That means dilution, right? So the dilution equation that you are accustomed to is mv equals mv. But guess what, ladies and gentlemen? The m's can actually be c's. And the c stands for concentration. So that means molarity can be used, and percent can be used, and parts per million can be used, and parts per billion can be used. Anything can be used in that equation, and it works. It doesn't have to be molarity every time, because we don't make things or report things in molarity every time. So that means that if I know the initial concentration that I made here, and I do, 1.034, right? 1.034 is what I started with. And I know how much of that I pulled. My initial volume that I pulled here was 25 milliliters. Well, I'm trying to figure out my new concentration. I don't know what that is. That's what I need to solve for. But I know what my final volume is. I put 25 mils of that liquid in here, and then I added water, and I went up to the line, and that gave me 50 milliliters, because it was a 50 milliliter volumetric flask. Okay, so now I know all the pieces to the puzzle. And I just need to go in and I just need to solve this. So 1.034 times 25 is 25.85, and that's equal to 50x. And then to solve for x, this is 50 times x. I do the opposite of, so I divide. So x is equal to, dun, 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 divide it by 50, 0.517. And this is ppm. My unit started off in ppm. My unit ends up in ppm. Okay, so over here, my high concentration was 1.034. My middle concentration, just now solved for that, that was 0.517. Took 25 mils, diluted it to 50. I cut the concentration by half, right? 25 and 50, they're half of each other. My concentration, they're halves of each other. Makes sense. All right, then I made a low standard. How did I do the low standard? Well, I did this low standard the same way. Nothing fancy here. Here's my volumetric flask. And I took out of this flask 25 milliliters and put it into this one. So once again, I used a pipette. 25 mils went in. This was a 50 milliliter volumetric. So again, I want to know what is the concentration of my low one. All right, well, I just did it. So let's come over here to the side and do it again. So CV is equal to CV. There's the dilution equation because I diluted. My initial concentration. What was the concentration of this flask that I pulled from? I just solved for that, right? 0.517. Well, how much of that did I use? I used 25 milliliters. Okay, so 25 goes there. What's the concentration of this new low one that I made? Well, that we don't know, so we'll keep that as X. And then what was the volume that you ended up making of that solution? Well, we diluted up to the line, and that was a 50 milliliter volumetric, so 50 is going to go here. So I do the same type of thing, right? To solve this type of problem, what I would do is I would take 0.517, and I would multiply by 25, and that gives me 12.925, and that's equal to 50x. I need to solve for x, so get it by itself. 50 times x, I divide by 50. So 12.925 divided by 50 is equal to 0.259. And that is the concentration of my low one. Okay, so let's just review for a couple of seconds. I went into the lab and took a jar of cholesterol. I went over to the balance and weighed out a certain amount. And I took those flakes and I put them into a volumetric and diluted it up to 100 milliliters because it was a 100 ml volumetric flask. My concentration, based on the calculations, is 1.034 ppm. That is what this flask is here. All right, so let me color code this. This 1.034 represents this flask. That's how I made it. That's what's swimming around in that flask for me to use. Well, I took a little bit of that and I put it onto the machine and I ran it. And I got an area. That area was 3,371,244. All right. But I know that I'm going to have to make a series of standards. I need to make what we call a calibration curve. The reason for that is that that's the only way that I can figure out what the concentration of my sample is. So I had to make standard number 2. We call that the middle. To make it, I took 25 milliliters of this guy, put it into a flask, and diluted it up to the 50 ml mark. That gave me a new concentration. That concentration was 0.517. That represents what was made in this flask. Well, that was my number 2 down. I go to number 3 now. Any 2 points make a line. I at least need a third one. So I did the same thing. I took a pipette. I pipetted out a certain amount here, 25 mils. Put it into another volumetric flask. Diluted up to the line with water. Shook it. Made sure it was mixed. And I calculated a concentration. That concentration was 0.259. And that represents the sample that was in this flask here. And I ran this one on the instrument, and I ran that one on the instrument, and here are my areas that go with each one. All right? So slowly but surely, we are working ourselves up to a calibration curve. But this is what has to go on beforehand. You have to know the concentrations of the standards that you have made. You end up making one most of the time originally from the very beginning. And then you dilute them from that point on. But you've got to know a starting concentration before you do anything else. Okay, so in the next video, we will then take these concentrations that I now know, and I will show you how to make a calibration curve using Excel.